Welcome back to the GreenMechTV channel. What used to be discarded as agricultural waste is now being transformed into a valuable and sustainable resource. This is the story of coconut husks, often overlooked yet full of potential, making their way from farms to factories that turn them into biodegradable products. The journey begins with the collection of discarded coconut shells and husks, which in many regions would otherwise be left to decompose or be burned, contributing to greenhouse gas emissions. But in this eco-conscious process, they're diverted from that path and delivered to specialized recycling centers. The fibrous outer layer, known as coir, is separated from the harder inner shell. The coir fibers are then cleaned, sun-dried, and processed into a soft yet durable material. These fibers are used to manufacture a wide range of eco-friendly items: garden planters, erosion control mats, brushes, ropes, mattresses, and even soundproofing materials. Unlike plastic, these coconut-based products naturally decompose and return to the earth without harming the environment. Meanwhile, the hard shells aren't wasted either. They're crushed and turned into activated carbon for water filtration, burned as biofuel, or shaped into decorative goods and homewares. This ensures that every part of the coconut is put to use, supporting the ideals of a zero-waste circular economy. The process is clean and energy efficient, often powered by local labor and simple mechanical systems that don't require large-scale industrial inputs. In many developing regions, this industry not only reduces waste, but also creates jobs and empowers local communities through sustainable enterprise. Moreover, these coconut-based alternatives are finding global markets, replacing plastic in packaging, agriculture, and household goods. Their use helps reduce plastic pollution, conserve resources, and support climate resilience through smarter material choices. By turning waste into something meaningful, this system redefines how we value natural resources. It's a perfect example of sustainability in action, rooted in simplicity, driven by innovation, and powered by the commitment to a cleaner, greener future. Behind every pile of discarded tires lies an opportunity, and this facility is proving just how powerful that opportunity can be. At Lead Reclaim and Rubber Products Limited, waste rubber is no longer a problem but a valuable raw material ready for transformation. The journey starts with the collection of used tires and rubber scrap from a wide range of sources, from cars, trucks, and industrial equipment. These materials are first sorted and prepared for processing, then fed into massive shredders that tear them apart with industrial-grade precision. The resulting fragments are systematically cleaned and separated. Steel wires embedded within the tires are extracted using powerful magnetic systems, while fibers and other contaminants are removed through air separation and filtering. What remains is crumb rubber, a fine, high-quality material that can be repurposed in dozens of sustainable ways. From rubberized asphalt for quieter, more durable roads to soft, impact-resistant playground surfaces and shock-absorbing running tracks, this reclaimed material is giving rise to infrastructure that's not only useful but also eco-conscious. Beyond rubber, the facility also reclaims valuable steel components, which are cleaned and sold back into the metal recycling stream. Every part of the tire is accounted for, reducing waste, conserving resources, and contributing to a closed-loop circular economy. The plant itself is designed for safety and environmental control. Ventilation systems reduce airborne particles, enclosed conveyors minimize contamination, and staff follow strict handling procedures to ensure efficient, responsible processing. A fully loaded garbage truck pulls up and begins offloading its massive haul. As the hydraulic bed lifts, tons of household and commercial waste slide out, a daily reminder of how much we throw away. This is the first step in the waste management chain, where collection meets sorting, recycling, or landfill. It's a crucial moment in the journey of our trash, and a powerful image of why sustainable solutions matter. This is the multi-crusher, a powerful machine designed to process municipal solid waste with speed and precision. As mixed materials are loaded in, the dual-shaft system tears through everything from plastics and wood to textiles and packaging. The result? Uniformly shredded waste ready for downstream sorting, recycling, or energy recovery. With high torque and low speed, it minimizes dust and noise while maximizing efficiency. It's a key part of modern waste processing, helping cities reduce landfill use and recover valuable materials from the trash stream. Construction and demolition sites generate enormous amounts of waste, but instead of sending it straight to landfills, modern processing plants like this one are reclaiming valuable materials and reducing environmental impact. As trucks arrive, they unload a mix of debris, broken bricks, concrete chunks, wood, glass, plastic, and metal. The material is first inspected and pre-sorted by heavy equipment to remove oversized objects and hazardous waste. Concrete and masonry are transferred to crushers, where they're pulverized into reusable aggregate, perfect for roadbeds, foundations, and future building projects. Meanwhile, conveyor systems move the remaining material through several advanced separation stages. Vibrating screens sift out fine particles like sand and dirt. Air blowers separate lightweight materials such as plastic and insulation, while magnetic separators extract iron and steel components for recycling. Wood is cleaned and chipped for use as biomass fuel or composite board production. Plastics may be shredded and sent to recycling centers. Even drywall can be crushed and reused in new manufacturing processes. At the end of the line, what remains is only a small fraction of the original load, dramatically reducing the burden on landfills. This integrated system doesn't just recover raw materials, it reduces emissions, lowers disposal costs, and turns demolition into opportunity. It's a smart, sustainable solution to one of construction's biggest challenges, proving that even rubble can be part of a cleaner, circular future. Bulky furniture waste, like sofas, armchairs, mattresses, and wooden cabinets, has traditionally been a nightmare for waste management systems. It's oversized, filled with mixed materials, and incredibly inefficient to transport or landfill. But the Kumar Ogre Compactor offers a smart, industrial-scale solution that combines power with precision. As each full-sized piece of furniture is loaded into the massive hopper, a rotating steel auger begins its work, slowly, steadily, and relentlessly. This isn't high-speed shredding. It's a high-torque, low-speed grinding process designed to handle dense, tangled, unpredictable waste. The auger pulls the material inward, crushing wooden frames, twisting metal springs, and compressing foam, fabric, and stuffing into compacted output, all in one continuous motion. The system's engineering is built for durability. Unlike traditional hammer mills or shear shredders, the auger has no sharp blades to dull or jam. Instead, its spiral-driven shaft exerts immense pressure, breaking materials down without requiring sorting or pre-treatment. This reduces labor costs, increases uptime, and significantly improves throughput. What makes this especially powerful is the volume reduction. Sofas and chairs are largely made of air. Once compacted, the waste occupies a fraction of its original size. This means fewer truckloads, lower fuel usage, and reduced carbon emissions. Some setups even incorporate smart compaction metrics and automated bin filling systems to optimize hauling schedules and costs. After compaction, the dense output can be pushed into containers for transport or fed into balers for further processing. Any embedded metal can later be extracted with magnets, enabling partial material recovery in the recycling chain. The remaining composite waste can go to energy from waste facilities or be stabilized for responsible disposal. The Comar system is especially valuable for municipal waste stations, transfer facilities, and large-scale recycling hubs. It empowers cities and contractors to deal with an ever-growing wave of post-consumer bulky waste, particularly in an era where online furniture sales and disposable home goods are on the rise. At its core, this technology reflects a shift toward industrial efficiency with an environmental conscience. It doesn't just destroy, it deconstructs with purpose, making room for smarter waste logistics, greener infrastructure, and cleaner cities. In a world where landfill space is finite and sustainability is urgent, machines like this aren't just helpful, they're essential. In an age of ever-increasing industrial waste and dwindling resources, recycling technology has had to evolve, becoming not only more efficient, but also more powerful. And few machines embody this evolution better than the high-torque shredder we see in action here. A true beast built to devour the hardest forms of scrap metal with precision and ease. What we're witnessing isn't just destruction, it's transformation. At the center of the action is a cast-iron manhole cover, a seemingly indestructible object forged to withstand decades of pressure from passing traffic, erosion, and time. But in the jaws of this industrial shredder, even the toughest materials have limits. The machine itself operates with dual shafts, interlocking, counter-rotating spindles fitted with hardened steel teeth. As the manhole cover is fed into the hopper, it's pulled downward with staggering force. The initial resistance is brief, but impressive, until the torque overcomes the metal's integrity. There's a distinct crunch, a twist of fractured iron, and then the entire object is reduced into jagged chunks, ready for the next phase of recovery. This isn't a one-time show. The shredder handles a continuous stream of dense materials, oxidized pipes, metal beams, vehicle suspension parts, outdated machine components, and structural waste that, until recently, would have gone straight to landfill or sat unused in scrapyards. Each item meets the same fate, torn apart methodically and rendered into fragments that can be further sorted, melted, and reused. Yet what's truly remarkable isn't just what the machine destroys, it's what that destruction enables. With every rotation of its twin shafts, it untangles complexity. Furniture frames embedded with nails, multi-layered metal castings, hybrid composites, all are homogenized into manageable pieces. This mechanical digestion opens the door to a second life for materials that would otherwise remain locked away in landfills. It's an industrial reset button, making the impossible recyclable and the unsalvageable usable once again. The brilliance lies not only in the brute force, but in the design logic. The low-speed, high-torque mechanism ensures minimal dust, low vibration, and quiet operation, crucial when installed in urban or enclosed recycling facilities. The slower rotation also allows for safer control of unpredictable materials, like spring-loaded parts or dense castings. that could otherwise jam or damage conventional shredders. Beneath the shredding chamber, a sizing grid ensures that only appropriately sized fragments move on. Larger pieces are caught and returned for another pass, a self-regulating cycle that ensures consistency in the final output. This uniformity makes it easier for downstream sorting. Magnets extract ferrous metals, eddy currents separate non-ferrous ones, and the rest can be repurposed into aggregates or fuel for energy recovery systems. Environmental impact? Tremendous. Recycling a single ton of steel saves roughly 1,100 kilograms of iron ore, 630 kilograms of coal, and 55 kilograms of limestone. Now imagine that amplified across hundreds of tons of material processed daily. Add to that the reduced transportation volume, since compacted metal takes up far less space, and we're looking at a meaningful cut in emissions across the entire supply chain. But there's a deeper narrative here: responsibility. Machines like this don't just exist for convenience or spectacle. They reflect a shift in industrial philosophy, one where nothing is truly waste until we decide it is, where the afterlife of products is considered part of the design process, where heavy industry and environmental care are no longer in conflict but in collaboration. The machine's automated features help support this vision. Real-time load sensors, automatic jam reversal, and overload protection ensure smooth, safe operation, while dust suppression systems and enclosed control panels protect both operators and the environment. Some models are even equipped with remote diagnostics and data logging, enabling predictive maintenance, optimizing uptime, and minimizing unexpected breakdowns. Every crushing cycle is a step in reclaiming value, not only in metal, but in purpose. These manhole covers once served beneath city streets, silently carrying the burden of infrastructure. Today, their story doesn't end with disposal. Instead, they're reborn as construction steel, new machinery, or even parts of another shredder, beginning the cycle again with renewed potential. This is the future of waste: industrial, intelligent, and intentional, where we don't just dispose, we deconstruct, we recover, and we rebuild. And it all starts here with a roar, a twist, and a machine that refuses to let even the hardest materials go to waste. Meet the PowerHand VRS, a powerful vehicle dismantling system designed to strip cars with speed, precision, and control. In just seconds, it rips through hoods, crushes frames, and peels away components that would take hours to remove by hand. With its hydraulic claws and rotating grapple, the machine targets high-value parts like radiators, wiring, and catalytic converters, making them accessible for resale or recycling. Every move is calculated, reducing labor, increasing safety, and maximizing material recovery. By the end of the process, what's left is a skeletal shell, ready for shredding or compaction. Machines like the PowerHand VRS are revolutionizing auto recycling, turning end-of-life vehicles into resources, not waste. The PowerHand VRS vehicle recycling system is more than just a dismantler. It's a precision-engineered solution designed to tackle the growing challenge of end-of-life vehicles with speed, safety, and maximum material recovery. At the heart of this machine is a high-powered rotating grapple and a hydraulic shear. Together, they make quick work of even the most stubborn parts of a car. As the vehicle enters the dismantling zone, the operator uses joystick controls to target key components like engines, transmissions, radiators, catalytic converters, and aluminum frames. With a twist of the claw and a pull of the shear, each part is cleanly separated from the body without unnecessary damage. This approach is far more than brute force. The system is designed for surgical precision. The grapple rotates 360 degrees, allowing operators to access difficult angles with ease. Hydraulic arms deliver consistent pressure, giving the machine the ability to extract high-value components intact, perfect for resale, reuse, or targeted recycling. Traditional vehicle dismantling can take hours and involve multiple workers using hand tools. But with the PowerHand VRS, a single operator can reduce a car to its recyclable components in just minutes. This not only improves safety by keeping workers out of the danger zone, but also dramatically reduces labor costs. Once the valuable components are extracted, the remaining car shell is clean and lightweight, ready to be sent to a shredder or crusher. By pre-stripping materials like copper wiring, plastic tanks, aluminum parts, and catalytic elements, the system ensures that downstream recycling operations are more efficient and less contaminated. What makes this system truly sustainable is how it transforms the economics of recycling. Every car becomes a modular source of raw materials, ferrous and non-ferrous metals, polymers, electronics, all sorted and ready for reuse. This reduces dependence on virgin mining, lowers emissions across the supply chain, and brings us closer to a closed-loop system. The machine itself is designed for heavy-duty operation in tough environments. Its reinforced arms, wear-resistant grapple, and responsive hydraulics ensure long-lasting performance. Many models also feature telematics and diagnostic systems, enabling maintenance teams to monitor performance and prevent downtime. Whether in a scrapyard, a recycling center, or a municipal facility, the PowerHand VRS offers a smarter way to process vehicles. It turns what was once waste into opportunity and transforms old, forgotten machines into the building blocks of a cleaner, more efficient future. As global vehicle numbers continue to grow, so does the need for smarter recycling systems. Machines like the PowerHand VRS don't just make the job faster, they make it cleaner, safer, and more circular. This is industrial progress with purpose. A machine built not only to break, but to recover, to give every car a second life, one part at a time.